Let's talk about functions. The very first problem asks us to determine whether the following relations are functions. Remember that a relation is just two variables linked together somehow. So it could be x and y with ordered pairs, it could be an equation, but a relation just has two variables relating to each other. A function is some special relation where every x value has only one y. Think of it as a marriage almost, because when you are legally married to someone, you're only married to that one person legally. You can't be legally married to two people. So what we're going to do is we're going to go through, determine whether or not they're functions, and regardless if it's a function, we are going to state the domain and range. Remember, domain is x, range is y. So here, when we look at our ordered pairs, let's look at the x values. We have a 1, 2, 3, 4, 5. Our x values do not repeat. And if our x values do not repeat, that means that each x has only one y. As soon as that happens, it is a function. Now that we have established it's a function, we can go ahead and find the domain and range. I know that we were working previously with interval notation, but when you're given ordered pairs in this manner, you can't do interval notation. We can only list what is there. So we're going to use set notation, which means we're going to have a curly bracket, and we're going to list all of our x values, which we said were 1, 2, 3, 4, 5, and close my bracket. I separated each one with a comma. My range is all of my y values. So my y values are 1, 2, 5, 10, 15. Looking at our next one, part B, need to determine if it's a function. So let's look at our x values. We have 1, we have -2, -1, 1. And then you're thinking to yourself, wait a second, that's not okay. Because here we have two different values associated with x equal to 1. We're saying that x equal to 1 is married to -2, and x equal to 1 has y equal to 3. Trying to be married to two people at the same time legally is not okay. So this guy is not a function. He's still a relation, just not a function. Even though he's not a function, we can still do the domain and range. I'm going to go ahead and highlight my last x value because I'm going to need him for my domain. Again, some curly brackets. It's not the best curly bracket, is it? Try that again. Starting with our first x value, we have 1, -2, -1, 1 from 1, 3 is already on the list, so I don't need to write it again. And then 4 is my last x value. My range, remember, is all my y values. I have -2, 0, 2, 3, 8. And you may be asking yourself, is the y allowed to repeat? For functions, yes, the y is allowed to repeat. The x is not. Our next couple of examples, we're going to find domain and range of graphs. And we need to determine if the graphs depict functions. So essentially, if whatever drawing we have is a function or not a function. Remember that your function, if you pass the vertical line test. Now, the vertical line test says that if you can take your pen, lay it flat, and make it vertical, if you can draw vertical lines through your function without hitting the function more than once, or hitting the graph more than once, it's a function. Here, because I can draw several vertical lines where I am touching the graph in more than one place at a time, this guy is not a function. He failed the vertical line test miserably. But even though he's not a function, we can go back and still find the domain and range. We are going to use interval notation this time because we're not just given ordered pairs. We're given a graph, which means that we can hit all those little fractions and other stuff, like pi. Okay, so domain, remember domain is our x. We're going to look at our graph from left to right because we want smallest to largest. The smallest x on the left is -4. So we're going to have -4 with a bracket because we can actually hit -4. And then we scroll over to the right, and the farthest we go is x equal to +4. So we're going to do comma 4 again with a bracket. Now that we have domain, we can look at our range. Remember, range is our y values. We need to go smallest to largest again, so we're going to start at the bottom and work our way up. Our smallest y value is at -3, and we actually hit -3. So I'm going to put a bracket, and we scroll all the way up, and then we hit our ceiling of y equal to +3. But again, we're actually hitting 3, so we're going to use a bracket. Part B is similar. May look a little scary, but don't worry. We're going to be all right. Remember when it is a graph like this and it does not have like a closed dot or open dot at the end? That means that the graph is going to keep going. It's got a little arrow on it. First thing we want to do is see if it passes the vertical line test. So again, if you lay your pencil flat, make it vertical, you can scroll over from left to right. I'm going to draw lines. You can use your pencil. And you can see that we are not hitting the graph more than once when we draw the vertical line. Like in our last one, every time we drew a vertical line, we would hit the graph at least twice. So here, because it passes the vertical line test, That means that we have a function. He passed the test. All right. Let's go on to our domain and range. Remember, domain is our x values. We're going to go smallest to largest. Remember, the smallest is to the left. We said that this graph keeps going because that arrow at the end. So that we keep going and going and going and going, which means eventually we're going to get where x is 10, negative 10, and then where x is negative 100 and negative 1,000. It may take a while, but they'll get there eventually. Because our graph is still going and going with that arrow, and it's going to the left, we're going to say the smallest is negative infinity, and then we read from left to right. Coming to the right, we get stopped right here. But notice that something special is going on at x equals 0. Here we are hanging out in the origin. It's an open circle. Remember when we were graphing our rationals, an open circle meant that we could not include the value. It was a hole. It was taken out of our domain. So when we have 0, we're not going to use a bracket. We're going to use a parenthesis. Let's look at our range. Remember again, the range is the y. We're going to start with the lowest, the smallest, and then work our way up. This is like part of a parabola that got one of its arms chopped off. So you may remember how to do this. This is our quadratics. Looking at the bottom, our lowest y value is negative 4. We actually hit negative 4, so we're going to put a bracket. And then if we start looking up to find our y values, notice that our graph keeps going and going and going and going, like I mentioned earlier, which means eventually we are going to get to y equal to 10, y equal to positive 200, y equal to 1,000,000, if we actually stuck around to see what the graph was doing for that long, which means we're going to go up into the positive infinities. And remember that positive and negative infinity always have parentheses. We have a couple more of these. So looking at part C, this one may be a weird looking graph. So let's get some ordered pairs in here for you. Oh, sorry, technical difficulty. Here we go. Okay, so over here on the right-hand side, we have an ordered pair. It wasn't an open circle, so closed dot is fine. And to the left, it goes off the page. So again, I have an arrow going to the left, and it just keeps going. If I do the vertical line test, I'm only hitting the graph once each time I do my vertical line, which means we pass the vertical line test and we do have a function. After we've determined it's a function, we can do the domain. Remember, domain is x, smallest to largest. To the left, we have the arrow, which means it just keeps going and going further into the negative x values, which means we have negative infinity. And then when we move to the right, trying to find our highest, we stop at x equal to 5. And like I said, when we were first looking at the graph, since it has a closed dot, I'm going to have a bracket. Let's look at our range next. And again, range is y. Looking at our smallest value. So if we're covering our graph, trying to find where we start, everything that is in green does not exist. We do not start moving our way up until y equal to 3, which means our range is going to start at 3 with a bracket because we have the ordered pair there. And then it's going to keep going up because of that arrow we have on the left-hand side. Yeah, we're getting more and more negative on the x, but it is still going up, which means that we are going up in our y values, which means our range is positive infinity.